All right, this is where we left off. Hey, maybe I could have put this in the previous video. It's only a couple of slides on inductive logic, but try to be mindful about the length of these videos here. So let's just talk about the last couple of sections in this note before we shift over into the problem-solving literature here. So inductive logic is the opposite of deductive logic in a way. So deduction, as we saw, is starting with these general principles or general statements. We narrow it down to a conclusion about a specific case. Well, inductive logic starts with the specific cases, right? And so if I have a couple of specific cases, I'm going to try to use that to then make a statement, a more general statement, a more broad statement to explain my specific cases. I oftentimes like to kind of compare this to pattern recognition, right? Pattern recognition is when I see something happen and then I see another thing happen and I say, these two things have something in common. So that means they're sharing a pattern, right? And as I see this thing happen again and again and again, I'm starting to notice the pattern. So I'm thinking, what's causing the pattern? So then if I make a statement about what I think is causing this pattern, that's the general statement, and that's inductive logic. So one example of this is the cloudiness, right? Where does this come from? So I'm saying if it's cloudy today, it's going to rain. Now, is that true? Well, it might be true, it might not be true, right? Is it valid? Well, it's not deductively valid, but it might be inductively valid. So where does this come from? Let's break it down. What I'm noticing is that on days where it's raining, it tends to be cloudy. And if it's not cloudy, there's no rain, right? Um, so uh, in this case, I notice a pattern, right? I'm noticing that there's clouds, it's cloudy, and maybe even I notice the clouds look a certain way. They look a little bluish and purplish and heavy and dark, not just like white, fluffy clouds kind of sparsely scattered across the sky, but a heavier concentration of darker clouds, right? So I see this pattern, and every time I see this pattern, it's accompanied with rain and storms. So over time, I just walk outside and I see those clouds and I'm thinking, yep, looks like it's going to rain, right? That's an inductive logical statement because I'm basing that based off of all of the patterns of different kinds of cloud structures I've seen in my life. And I know which ones mean rain and which ones most likely don't mean rain. And so are we right every time? No, right? Sometimes those big, scary purple clouds just float right on by and they never drop a single drop of rain, at least not on us. Maybe it rains somewhere else, but not on us, right? So we were wrong, but at least it is based in some, actual form of pattern recognition, like I said. Same goes for claiming the sun rises in the east every day. Obviously, there are formal scientific models of the solar system that can explain how this happens. And excuse me, based on those formal models, we can make deductive statements about where the sun's going to rise every single day. But even in the absence of knowing anything about how that's supposed to work, I can simply wake up every morning and notice where the sun happens to be. And that becomes a pattern that I can then claim if I happen to wake up a few minutes before sunrise, I can say it's going to happen right over there. And I can say that's it. And of course, I'm right because that's inductive logic. That's a bit more of a consistent example, so I usually will be more right than wrong compared to predicting rain, right? But nevertheless, still the same kind of logic here. Now, this idea that we might sometimes be right and sometimes be wrong with induction is an interesting way to contrast it with deductive logic, because deductive logic kind of falls into this all or nothing kind of category, right? Where if the premises are true and I'm engaging in valid logic, then my conclusion is true, right? It's kind of a 100% thing there. And if my premises are false and I engage in valid logic, then maybe I end up with a 0% chance of being true, right? So the idea is that deduction tends to fall under this kind of all or nothing, valid, invalid, true or false kind of situation here. Induction is more associated with probabilities, right? That it's probably better to say that when I see the clouds, I should not state with certainty it's going to rain, right? But I should say, as I've written here, it'll probably rain, right? Well, I think there's a high probability of rain. So when I walk outside and I see those clouds on the horizon, I think there's a high probability of a storm. When I see a clear blue sky, I say there's a low probability of a storm. In each one of these cases, those probabilistic statements are likely to be generally true. But as you know, if you live in Florida, those rain clouds can roll up on us real fast out of nowhere on a sunny day, right? So there's still a chance we're wrong at some point, right? But one thing I want to say about all of this stuff here is that because the inductive logic is more in that kind of middle ground of probability, I want you to think back to the previous chapter, because in that previous chapter where we talk about base rate fallacies, what we learned is that people don't reason about statistics and probability in it very, very well. So this would lead us to suggest then that when we make these kinds of probabilistic statements based on past experiences, then we might fall victim to things like the representativeness bias. So just because those clouds that we're seeing are representative of storm clouds doesn't mean there's going to be a storm. All right, that's the concern here, right? Or based on the availability heuristic, certain things that are more memorable, I think they're going to happen because I'm more likely to think of it. But again, that doesn't mean it's really going to happen. And the same now applies to our confirmation bias, right? This is another bias that we could have mentioned in that previous chapter, but here it is in this chapter. So the idea here is that our confirmation bias means that I have pre-existing beliefs, and because of that, I'm going to think certain things are more likely to occur and or less likely to occur because of my beliefs. And then when those things occur or when they don't occur, conversely, I will notice that and I will then treat that as further evidence of my belief. But when the opposite happens, I tend to not pay attention to it. So what I think we also want to think here, at least it works in my mind, that the confirmation bias runs a little bit parallel to the availability bias, right? The availability bias is this idea of things that are more memorable to you having a stronger effect on your judgments. Well, the idea is that the confirmation bias can influence exactly how memorable certain outcomes are versus the ones that are not memorable, right? Let's go with this example that I have at the bottom. John bought a new UCF sweatshirt and he wore it the very next day. And on that day, he gets an A in his cognitive psych exam. The next week, he wears it to a chemistry exam and he also gets an A. So now he thinks that this is his lucky shirt. So what's he going to do? He's going to start wearing it every time he has an exam, right? Now, what actually happens in reality once John starts to wear this to every single exam he takes for the rest of his college career? Sometimes he might get an A on the test. And when this happens, he then says, look at that. That's my lucky shirt paying off, right? Now, sometimes maybe he doesn't get an A. So what does he think about those situations? Does he treat them as what we'll call disconfirming evidence and then causing us to think that, okay, maybe my belief that this is my lucky shirt is not true and I need to disconfirm that and stop thinking of it this way? Well, that could happen, but we wouldn't be calling it the confirmation bias if that really happened a lot, right? So what may be more likely to happen is that he tends to ignore those situations where the shirt does not pay off and get him an A on the test. So what this then means is that if we were to ask him, hey, you believe this is your lucky shirt, right? Does that mean you get better grades when you wear it versus when you don't wear it? Let's think about that too, by the way. Let's say that sometimes he forgets to wear the shirt on his exam days. Does he get A's sometimes when he's wearing a different shirt? He might, right? So the belief here that the sweatshirt is a lucky shirt would seem to be rooted in some factual statement that the actual frequency of getting an A on a test is higher when wearing the shirt versus when wearing something else. That's not likely to be true because, of course, lucky shirts don't exist. But what happens here for John, because of his belief that is his lucky shirt, that means that every time the shirt appears to work, that is, he wears it and gets an A, that becomes something he notices, and he uses that to increase his belief. And every time the shirt doesn't work, he gets a worse grade, or every time he gets an A while wearing something else, he just doesn't even pay attention to those instances. So they don't really influence his belief. He only updates the belief every time there's a confirmatory experience. So now, of course, everything that confirms the experience does so, and everything that disconfirms the experience or the belief, sorry, does not. have any change, right? So then that means that if we were to ask him to talk about the base rate, right? So if we say, okay, is it really the case that you get more A's when you're wearing that shirt? He's going to say yes, because actually that influences now his perception of the base rate, which is where I said that this kind of feeds into the availability bias, that it's more easy for John to remember those situations where he got an A wearing the shirt, and it's less easy to remember those situations where he got a different grade while wearing the shirt, right? So that has led now to an illusory correlation, or right? He believes these two things are correlated, but they're actually not. And now, of course, that illusory correlation has led him to start to think about cause and effect. And what we saw with cause and effect reasoning here is that no, correlation doesn't prove causation, and that's all that John has here is even a distorted correlation, right? So there's two things going on here, really, which is one, even if there was a correlation that the shirt does seem to correlate with more A's, doesn't prove that it's causing this. But more likely is the case that it doesn't correlate at all, right? And the more often he wears the shirt, that correlation will decrease. That's a sample size effect, right? And but as that correlation decreases, he doesn't change his belief because the confirmation bias is keeping it up there, right? All right, so the next part of the section is on problem solving, but hey, let's keep this a short video. Why not? So we'll make a third part to cover the problem solving section of these notes. And as always,